coil contains n turns of insulated copper wire wound on a cylinder of diameter d. The copper wire has diameter d. The resistivity of the copper is rho, and the diameter d is much greater than the wire diameter d. Right, so there are two d's, capital D and small d. And the situation is, if I draw it over here, so imagine there's a cylindrical shaped, okay, and we have a wire of copper, and we've wound this copper wire on this cylindrical shaped object, and yeah, this wire has a diameter d, and the cylinder is having diameter d. All right, this copper got the resistivity rho, and what else do we have as an information? Right, so what is, okay, we got n number of turns. Okay, we got 1 2, so in total n number of turns we have. Now the question is, what is the total resistance between the two ends of the coil of the copper wire? So we need to figure out the resistance, the total resistance from here to here. So this is a length of wire, right? So we need to figure out the resistance of this wire. So if you connect an ohm meter between these two ends, you must get a certain value of that. So we need to calculate that value. So what could be our strategy? Well, first we need to know the formula for the resistivity. The resistivity is rho equals to R L over A. All right, sorry, R, the resistance R equals to rho L over A, where R is the resistance. Okay, this is the total resistance. Rho is the resistivity which is given to us. L is the total length of the wire, right? And A is the cross-sectional area. Okay, the cross-sectional area of the wire itself, cross-sectional area. Now we need to find the total resistance. We know the rho. We already know the rho. What is rho? But we don't know the L of the wire, right? So we just need to calculate the total length of this wire. Not the cylinder. Remember, the wire is wounded on the cylinder, so we need to figure out the total length of the cylinder, of the wire actually. Now, or also we know the cross-sectional area, because we know the diameter of the wire, so we can calculate the cross-sectional area from there. So if I just compute it, so R equals to, we know rho. Now L, as far as L is concerned, see, L is wounded on this resistor, right, on this cylindrical shaped object, right? So R must be making diameters, making circumference. If I just calculate all the circumference, if I just calculate the circumference of the cylinder and multiply with that, if I just calculate the circumference C and multiply it with N, because N is the total number of turns on that cylinder, right? If I just calculate the circumference of the cylinder multiplied with total number of turns, it will give me the length of the wire, right? That's the concept. Now, the circumference of the cylindrical shaped object will be, okay, 2 pi and R. The diameter is D, so I can calculate R by D by 2, right? And multiply by N. So this is the circumference times the number of turns will give us the length of the wire, divided by the cross-sectional area. Now the cross-sectional diameter, the diameter of the wire is D. So the cross-sectional area will be pi D square over 4. All right, pi D square over 4. Now we just need to rearrange this formula to make it more simplified version. So this will be R equals to 4 rho pi, this 2 and this 2 will cancel out. So 4 rho pi D N over pi D square. Alright, this 4 will be multiplied over here, and this will be multiplied by 1. And this will be pi D square, and this will be 4 rho pi D N. So pi and pi will cancel out, and we will be left with, so total resistance will be equal to 4 times the resistivity times the bigger diameters times total number of turns N, and divided by D square, where D is the cross-sectional diameter of the wire. So let's see if we got any option matching. Yeah, we got the option A, which is 4 N rho D over D square. So that's the right option.